So you guys are going to be my guinea pigs for this, and let's find out if other people are showing up, and let's also uh, let me also fire one off a quick email now. There we go. So the sync meeting is on now, letting everyone know about that. Let's get to, there we go. Let's get to what we're going to be talking about. So first of all, the exam is next Thursday, I do believe. I could make it, well, I could, the theoretical idea was, hey, it should be on Tuesday or Thursday because that's when the course is, and therefore that's when you're supposed to have those hours blocked off in your schedule. Of course, in reality, that's not true, and most of you have picked up other stuff along the way, and or you have other classes just beforehand. I appreciate, unfortunately, that that's the case that you guys have to go through. But because the course outline said it was on this Thursday, I have to make it on this Thursday. So this Thursday, the week from now is Thursday, sorry, the 26th, I do believe. So that's when the online exam number 2 is. It's 90 minutes. I'm going to try and make sure that we don't have problems with the timing again like last time. I'll also have it automatically submit, unlike the last time, just so we don't have the panic-inducing situation that was the last exam. Sorry. So here's the plan of attack. Is it's going to be very similar to the last one, but of course longer. It's 90 minutes. I'm designing it to be done within 90 minutes. I know, what a novelty. It's already actually written. I want to clip it down a little bit because one of the TAs took, I think, 60 minutes to do it, and I want to have them being done in like 30 to 45 minutes kind of thing. There's not a really a lot of memorization in that exam. It is how to do things. Like if you do not know how to make an object or how to make a class, there's a problem. If you do not know model view controllers are fair game. Microsoft Foundation classes, not so fair game. They're not on the exam. You need to know about inheritance, polymorphism, information abstraction, information hiding, data abstraction, which is sort of the fancy pants term. Okay. The sample midterm, I'm trying to remember here. The sample midterm, is that a paper one? If it is, it's going to be different, obviously. But that's the style of question I ask, but the formatting is going to be different. Much like music is the same, but when it's on vinyl versus when it's streamed, it's different because how you consume it is different. So they're not going to be identical if it's based on a paper exam like I think it is, but it does mean that that's the style of question I ask. Does that answer your question, Alex? I think it was Alex that asked that.
Yeah, hi. So the reason I was asking is I don't know about everybody else. For me, I really kind of froze on the first exam,
Mhm.
really badly. And so I was hoping that like if I can do the sample midterm and answer it kind of fine within that time amount, it would give me an idea of how prepared I was. Because I was just completely taken up. Like I'd studied for the first exam and I was completely taken aback by how much my brain froze.
Mhm.
Um,
The One of the things I hate about that first exam, and I will fully admit I hate certain aspects, large chunks of it. I pushed too hard, I think. Yeah, I think a lot of people did freeze on it. And number two, at a 30-minute exam online, it's very panic-inducing. It completely is. And so I don't know how to avoid that panic induction other than at an hour and a half, it means more questions can be asked, but more time to recenter yourself as well. And so I think the first exam was a catastrophe in my books. At least it was not up to my standard. I was attempting to be the best exam I could make it, but it did not meet my standard, did not meet your standards either. Um, Rightfully so, right? I mean, it's if you can miss the mark because you can't run that exam twice. You cannot, do a trial run of the exam other than with TAs. And when you have your TAs do it and they say, yeah, it was okay, um, that's all you can really go on. Uh, I'm not sure they did the trial run the first time, and so I'm making sure that they're doing the trial run this time. But yeah, I'm going to try and hit the best I can. I also know I cannot push as much as I was originally planning to. So the I'll blame some of you guys for that were my previous students from 1400. I really am not blaming you guys, but the 1400 class last winter did such an amazing job that I was just like, oh yeah, I can throw whatever I want on them. And that's the problem with the recalibration coming into this term. I knew some people were rusty or did not have a very good experience with 1400 the last time around, but I did not realize just well, I'm not sure how lost my old former 1400 students are, but I didn't realize just how much I was going to be crushing the hopes and dreams of people, and which is not my intent. So I'm hoping it is, I can't say it's easy, but it's because not easy, but it's also not brutally hard, I hope either. It's designed to be, if you've been doing this stuff and you've been working at it, it should be like, yeah, I know how to do that. Versus if you don't know what an object is and you've copied from your friends, or you've been looking at Chegg or something using Chegg instead, then you're host, right? That's where I'm hoping for. That it's not, um, it's perfectly reasonable. There should be no questions that are completely out to left field. There shouldn't be any questions where we have to sit down and think for 40 minutes to come up with the solution. But you need to have done, if you've done the assignments, you've done the homework, you've done the labs, it should be fairly easy stuff, right? Very similar to what we've done in the assignments, enough to make you think, oh yeah, I remember seeing this before, or oh, that seems similar to something else. In case you guys were in the, how do I want to frame this? There's a natural tendency for myself and most people to want to code this, and that's perfectly fine. You can use an IDE while you're doing the exam. The fear I have is that when people use an IDE for the exam, if it doesn't compile, they don't pass something in, or they start panicking and they start just obsessing over making sure it works and that everything is right. Versus on paper, you do a good enough job and you pass it in, or you move on to the next question, right? It requires a different balance of how you do things. I think you should be able to save your exam as you go. If I'm wrong, please correct me. So if you can, I would suggest doing a question, doing as best you can. If it doesn't compile, fine. Put it down, move on to the next question. And if you have time, go back. But don't try and make sure that first question is 100% correct. Then move on to the next question to make sure it's 100% correct. Because what ends up happening is people waste way too many times on like a 10-point question instead of like a 25-point question. It's designed to be, I can tell you this, I think, there are 70 points on the exam. Why? Because it doesn't really matter how many points are on the exam. There are 70 points on the exam. So it's about a minute a point and then 20 minutes to look over the exam afterwards. That's how it's designed. So that you can go like, it's a 20-point question. I should be spending 20 minutes on it. If I spend 25 minutes on it, maybe punt and move on and come back to it later. You should be getting approximately that your mark that you get should be percentage correct, right? Like, I'm not worried about, oh, you're missing a semicolon. But if it looks like the code is just completely out to left field, so I don't want to get people in trouble, and I'll look at the chat in a sec right now. I don't want to freak people out. I had, in a previous term for 2400, I gave them a bunch of code from a class for them to look at, like 2 pages of, fairly wide, but 2 pages of code for them to look at. I asked them a question, and I had people literally just retranscribing the code that I gave them on the piece of paper as their answer. They just rewrote it, hoping for the best. And you're like, you wasted time, right? I'm not going to give you points for you just rewriting what I gave you. It's about how you think about it. So let me see what your question is here. I guess my question is, if we do the practice at midterm and do okay, is that a good indication? It should be a very good indication. I can't unfortunately make any guarantees, just like my professors couldn't make any guarantees for me either. If you're doing fine in your on the practice midterm, yeah, it should be no harder than that practice midterm. There are things that are going to be different, though. I will give you that. Because it's later on in the term, I think the practice midterm gets up to polymorphism. there is the potential, you can also throw in model view controllers, events. I cannot ask you guys to write something with a model view controller. I cannot ask you guys to write, full-blown GUI Windows code, especially considering it's a half assignment, right? That's what this week is. It's essentially a half an assignment. I can expect you to have looked over that code. I can expect you to know how events happen, like that you get a mouse call back, then you deal with the mouse painting event, or that why you have model view controllers, why you separate your concerns, right? Your painting is different than your mouse and event control versus different than what stores your data. That's model view controllers, right? Those three things. So that could be different. I can ask like a multiple choice question on that, or I can ask, find the bug in the code. That's a fine kind of question I like to throw at people. If it was a model view controller, you can be finding the bug in the code, that sort of thing. Just hopefully that clarifies things. I think a lot of people are wanting that same question answered. What I was going to do, since the exam is the 26th or whatever the number is, not this week, this Thursday, but the following Thursday, I was going to leave this synchronous class around so that people can ask questions for the exam. I hope that works for people. What should you practice that are different? Some of it, as far as I know, there's nothing radically different. There's nothing term specific about the sample midterm. So if you can do it, I think it should be fine. It doesn't have any multiple choice. So how do I frame this? The sample exam, I thought it did have some multiple choice. Okay. I'm starting to give multiple choices now. The reason is the first time I taught 2400, I didn't give multiple choices, and we had people that got like 6 on the exam or 2, right? You get all or none versus multiple choice. If you're just randomly guessing, you're expecting, and for the multiple choice question, you'd expect 25%. That, of course, being said, I don't give easy multiple choice either. So does writing down? Yep. If you cannot write the code, write some pseudocode. You will not get 100% on it, but I definitely make sure I go out of my way. If you do not know what you're doing, like if you do not know the syntax of something, pseudocode. Yep, absolutely. If Panic gets better, use pseudocode. Whatever works for you. Now, the better thing to do would be to write the C code or C++ code and just, approximate it, right? If you're missing colon somewhere, if your thing is named wrong, if you're trying to make it, if that's why I'm saying if you're trying to force it to compile and it doesn't compile, don't worry about it. Pass that in. That's far better than trying to and so I'd rather, if you tried to code it and it doesn't work, I'd rather see the code than pseudocode. But if you can't even get the pseudocode, put in the pseudocode. I've had people cast in pseudocode where you're like, man, if you just did the assignments, you'd be golden. The pseudocode was perfectly fine. It was exactly how you do the problem. They just didn't have enough experience coding something to actually write any C code, right? I think this is in 1400. You still get a whole bunch of partial credit, but it's still pseudocode. It doesn't have the precision that real code does. Yeah. I think I even put the little instructions for the exam up. I finally revealed the exam, so hopefully that makes a bit more sense and you can look it over. If you have PMC accommodations, I need to make sure that it's set up correctly for you. And my I got to figure out with the PMC accommodations, because we have this window of how long the exam can be open for and how long you have for the exam. So you get a timer for your exam. And if you are supposed to get time and a half, let's say, so you get time and a half on your exam, but the exam closes after a certain point in time, does it close the exams for people, or are you still able to keep going? Is it closing into the start for your start of the exam? I got to figure some things out about CUlearn. I did have something to say about this though. If you have the PMC accommodations, Let me have a look at what was written down here, just in case it pops up in my head. There you go. It was going to come to me. I don't know what works best for you guys. The TAs and I discussed this a lot last time around because it was like, yeah, that was a big, big, big problem. Uh, it's very hard to keep track of time on an online exam. Normally, when I'm doing an exam in a class, I'm writing on the chalkboard, and people think it's antiquated. It's not, and well, it is antiquated, but it's not because I don't like technology. It's because the act of me walking out of the front of the class and writing on a chalkboard wakes people up just enough that they look up for a second and realize the time and how much time is left on the exam in a more subtle way than, hey, everybody, it's 20 minutes left. And so, what I would love to be able to do is give you some advance warning. It's very hard to do. So, I might be able to ping on Discord, but that's not really going to tell everyone the time. You're not all listening to some kind of, I can do a Zoom meeting and everyone's in the Zoom meeting just listening, and just in case. I don't know what the best approach here is, because I would like to be able to give you guys some kind of, there are 10 minutes left kind of warnings for the exam, uh, because I know I need to be able, I lose track of time. Like, oh, you have an hour left in the exam. I normally do about half-hour intervals and then 10 minutes, 5 minutes, and then done. Because I want to make sure that you can keep track of the time. And so you at least put down something in all the questions. If you have multiple choice questions left over, just answer randomly, right? Why not? Okay, can I answer any other questions about the exam? Otherwise, we can go on to what you guys want to talk about. Yeah, that's what I was worried about too. Uh, I mean, we could just all be muted all at once, but then there's back channels. There's a whole bunch of things. Uh, yeah, we could do a Zoom meeting open. The issue is just, again, that lag might be the issue. I was going to have Discord open, that you can ask questions, and we can always uh, transition to a Discord meeting if we needed to. Would Discord work for you guys? My fear is, of course, that if people start sending messages on Discord during the exam, you're going to get bing, 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 bing for every single time. So, uh, yeah, they really do fly faster online. It's a pain in the ass. I hate it. I have really hard time timing my exams as well. Um, so, how we think about it for a little while, I think Discord might be our best bet because hopefully it's not as obnoxious, and we can always boot somebody out if they keep on posting on Discord while the exam is going on. If you don't have Discord though, then it's a different thing. Um, but it would be nice to have some way of being able to warn everybody about how much time is left on the exam. Hopefully a subtle thing versus a slap in the face thing. Okay, so here's where I'm looking at things. For me, there's two different things that we can look at, and I'm actually working on one of them right now. Uh, so when I logged in first onto Zoom, I was busy plugging away at some code. Yes, because I code, for fun. It's actually not for fun. This is actually for a future lecture I want to do. I want to do one more lecture because I don't like my templates lecture that I have. That's for after the exam. Since I don't like my templates lecture, I wanted to give a nice simple example. So I'm taking my linked list thing, I'm stripping everything out as much as I can from linked list, and I'm going to make as simple of a template as possible for that, just to show that in action. I don't know if that's of any interest, but I think more likely people might be looking at model view controllers or something like that, because that's what the next assignment is, if you guys want to learn about that. Or do you want me to review any topics up to this point to make sure that you're prepared for the exam? I'm game for whatever. I don't want, last week we had me answering questions about one person's assignment. There's nothing wrong with that, but everyone else was like, screw that. I just took off. So I'd rather hit topics that are of interest to people. Maybe a model view controllers. Okay. Everybody else okay with that? Trees can definitely be on their link list, but will I ask you for Um, will I ask you for, hey, implement a tree? No, because the code is available to you, right? Will I ask you, hey, implement a linked list? No, because the code's available to you. Now, if a linked list shows up on the exam and you're asked to use it for something, well, that would be fine, because a linked list, we've done it for all these examples from all these different parts of the class. The code has been readily available to you. It's been used in various examples through all my lectures. It popped up again, I think, in the labs as well. It's things that were in class. You're expected to understand them, but not memorize and regurgitate. So why does a linked list work? What is it supposed to be? What is a tree? What does it look like? How does that work? Um, you might, and especially consider we did trees for assignment 1, assignment 2. Yeah, assignment 1, assignment 3. We did trees. So that would be fair game, even if it's not the same thing. It might be a tree with 3 children instead of 2, right? That would be a different question. You can't just pull the code from online. You can't just grab something and I'm not going to ask you to do, say, uh, write a linked list. Why? Because there's about 1,001 linked list examples online right now. Anyone could just steal one online, put it on the exam, and you're good to go. So it's going to be something with some constraints to it. Make a linked list with this variable name with these exact functions. So when someone grabs code online and plops it down in the exam, they get squat. If you try and write those functions with those names, then I know you couldn't have cheated, because if there's no other, that code does not exist online. I made the question up. And but before we started listing the things that we could expect. Oh, so what could we expect on the exam? So linked lists and trees can be on there. Model view controllers can be on there. So we'll look at that in a second. I'm going to have to go with the list myself. Strings, difference between C strings and strings. We looked at that for assignments 2A and 2B. We looked at trees from the point of objects and trees from the point of structs, assignment 1 and assignment 3. We looked at linked lists a bunch of times, but more importantly, we looked at what an object was, or what a class is, what an object is, destructors and constructors, the order in which they occur, for example, right? When I construct an object, what happens? When I destroy that object, what happens? We looked at pointers. So we had, when does a constructor get called? When I have an array of pointers. Well, it doesn't. It gets called when new gets called, but it doesn't get called for every pointer. It gets called for when an object gets created. We have things like, let me think here, information hiding. Why do we have public, protected, and private? What do those things mean? Why are some things protected? Why are some things private? Why don't I just give everyone access to all my variables? So the ideal is, if I have a linked list, you should not know how it's implemented. I can actually start showing that now, and we'll get on to model view controllers in for 2 seconds. So let me see if I can do the screen share. Hopefully I'm not going to give away something important. I hate the fact that I can have, there you go. So here is my simplified model view controller that I'm doing for the templating library, the simplified example. I just happen to have it open. Here we go. It's a linked list. It has a bunch of stuff in it. So the things in my linked list: it has a constructor, it has a destructor. Ideally, you normally wouldn't even put the function in there, but we'll look at this for templates in a second. We have a function called add. We have a function called get size. We have a function called get index, get whatever's at this index. We have a function called print the list. Yeah. We have another function called get previous. This is a protected function though, so only me and my children can look at it. The public ones, they're fair game. Anyone can look at these things. Get next. Well, let me get the next node on my list. But notice the protected function is allowed to say, hey, I'm using LL nodes. I'm using these little nodes in my linked lists. I'm stringing together these nodes. But no one else needs to know that. I want to have linked list. How is it implemented? I don't know. How do you use it? I put stuff on it. I take stuff off of it. Okay, that's all you need to know, right? You do not need to know how it's implemented. That's the point. So when you use strings, the string objects, how is it implemented? I don't know. No, neither do you. That's the point. You cannot make it some general tool if you have to figure out how it works. Again, I've been using this example a lot, so please bear with me as I'm acting redundant. But how many of you use an iPhone? None of you are using Linux-based phones. A lot of people were swearing that Linux is open source. People want to be able to look at the code. No, they don't. People want a phone that just freaking works. I want a tool that I can phone my friends with. I do not want to know exactly how many CPU cycles it takes to send off that text message. I don't care how this works. Most people don't jailbreak their iPhones, or maybe I'm naive in that respect. I don't think most people jailbreak their iPhones. They jailbreak Android phones all over the place. But an iPhone's designed effectively to be an appliance. That's what information hiding is all about. If you treat it like an appliance, if you do not know how this thing is implemented, your job is to hide all the gory details and just I have a magic thing called a linked list, or I could call it foo, it doesn't really matter. I have a magic device that I can shove crap into and take stuff out of. That's it. That's the reason we have information hiding. So if you knew what the variables were in my linked list and you could access them and modify them, you'd be hosed, because any application anywhere could go in and change those variables. You don't want that. You want to go through you don't want a backdoor into your class. You don't want some random other function to be able to just stomp on your data. You want to have to intentionally set that value with a set method. You want to intentionally get that value with a getter method. You do not want to know how this thing is built. No one wants to know how the sausage is made. If I'm going to borrow yet another expression, right? You don't want to know. You just eat the sausage, right? So if you have something that is like an object, like a class, you want it to be this sort of black box. Things go in, things come out. That's it. And that's what information is hiding is that down in here, I have private variables. No one knows about them. No one needs to know about them. They're mine. You just want to use this thing. When I'm driving my car, I really don't give a crap how it's put together or how it works. I want to turn the key, drive, hopefully not get into an accident, right? Other than when things go bad, most of the time, people don't care how things work. They just want to get on the elevator, push a button, and go up. They don't want to know, oh, well, it's using this kind of pulley relay system. Like, they just want the information. So that's information hiding. Uh, we also did inheritance. When I made a doubly linked list node, it took all the gooey goodness from linked list and made a doubly linked list, right? It's the same thing. I just have a couple extra variables and I re-implemented a couple of the functions. A better example of that, though, would be what we're going to get to now. So A5B starter, here we go. Hopefully it's not because I don't have all the answers in here. Oh, this is not the A5B starter. This is the code I used for the lab. So I showed this last time around. Let me show it right now. And this thing needs to go away. All right. All right. We have this weird thing where when I draw something, this is me clicking, dragging, letting go. That's how I made that box. When I'm just drawing a rectangle, it's not being done correctly. For rectangle and for the circle classes, two things are not being drawn correctly. They're not being drawn correctly because they're not broken into this model view controller architecture, this model view controller layout. I should have three classes that work together, model, a view, and a controller, but I pretend they're one. That's the idea. This one, this rectangle, doesn't pretend it's one class. It is actually one class. I do not have a view or a controller for this rectangle. So I only have this one thing. That's why it's being drawn incorrectly. I'll give you a hint. The controller is actually working because I didn't need to re-implement the controller. Okay, here is another. So here's another shape. Oh, I have the string. Okay, We're going to get rid of that one. And let me see here. You'll see, you might, no, that's a different thing. That's me playing around with some other things. Let's see if I have the animating one. Nope, triangle. This one's drawing correctly. So when my mouse moves, it gets mouse events. And when the mouse goes over top of it, one of those mouse events says, is the mouse inside the triangle? And it says, yes, it is. And okay, change your color. The model's color gets changed, or the flag gets set saying that the mouse is over top of this thing, that the shape is in focus. And if it's not in the triangle, despite being in the bounding box, it leaves focus. Okay, so every time I move my mouse at all, every single one of these shapes is getting a mouse event saying, hey, something changed with the mouse. And it can check to see if the mouse is in the shape. So this is using the bounding box to determine if it's in the shape for the text. This is using the bounding box to determine if I'm inside this thing. And hopefully I have the other one, Control Shift, let's say. Let's see if, there you go. And this is, again, using the rectangular bounding box. This is my animating rectangle. Hopefully it's not going to freak you guys out too much. I also have another event happening. I have a clock that goes off every 0.3 millisecond, every 30 milliseconds or something like that. I could make it even faster if I wanted to. But every certain amount of time that goes by, it says, hey, like just like your CPU is doing this as well, or a metronome setting off a beat. Every certain amount of time, a timer goes off, says, hey, everybody, wake up, check if your thing is animating change or animation has changed. And based on the amount of time that's passed, I change my animation. And so what I end up doing is, oh, the animation, the timer goes off. How much time has passed? Oh, 0.5 milliseconds. Okay, well, I'm going to change this much, or change this much, or change this much. And you change a little tiny bit each time. You do that fast enough, you get an animation. That's all this is doing. Again, it has a bunch of events. I have an event handler that handles mouse events. It handles timer events. It could handle keyboard events. It's the controller. And then that ends up talking to the model. The model stores everything. And every single time one of those events goes off and says, hey, something's changed, I say, hey, repaint everything. And so when I go to paint, that's the view. The view says, I'm going to paint. Hey, model, what do you look like? And you just get the data from the model. What you don't want is the following. I move my mouse. I get a mouse event. I then automatically then redraw the triangle while the mouse event is happening. Why? Because I don't know how many mouse events I'm going to get. I don't know how fast this thing is drawing. I could be drawing or maybe handle mouse events at 60 frames a second, right? The combinatorics, the number of ways this thing could happen really would hurt your brain, right? You can't get your head around it. It's too complicated. So instead, like everything you're going to see in programming, it is, you could make it completely free form, free for all. Like, who needs functions? Why not have go-to statements everywhere? What you don't, people are not that smart. We like structure. So I separate the 3 different tasks I'm doing and have completely different classes to do those 3 different tasks. And I don't try and combine them. I don't try and draw at the same time as a mouse event. I don't try and update my model at the same time as a mouse event, which is the same time as a drawing. I keep them separate because otherwise you will go nuts. Having gone nuts in the past when trying to do this kind of crap. Okay. So that is a model of what the model view controller looks like. Let's have a look at this thing. So here is shape 2400.h. I have a couple flags. I will get those for free. They might be private, but when I make a child class, those are for free. They are automatically in my child class. Every one of the functions automatically in my child class. If I don't do anything at all, the child class is exactly equal to the parent class. They're clones of each other. It's like get a clone and then modify the clone. If that's probably a better example than child and parent, right? You're getting a clone of the original thing. It's exactly the same, but now I can modify things slightly. So maybe that's not the best example. There's a old television show called Clone High that I really love. Famous people that get, they get cloned. So Abraham Lincoln's in the show, Mahatma Gandhi's in the show, Joan of Arc's in the show. And since they're clones of it, they're not the original people. And so the original people are these great people, human beings, and the clones, not so great, right? They're just trying to survive high school, essentially. So this is the same, like the clone is not the same as the original, but it is unless you make some changes. So I get those variables for free. I get this variable for free. I get all these variables for free. I get a background color for free. I even have a function called my intersect rect. It will give me the intersection rect. But let's look at some of these public classes. These are the things everyone has access to. So I have a constructor. I have another constructor. This one takes in a whole bunch of parameters. This is the one we always use. I have a destructor. Again, you don't have to change that. I can get the bounding box. If the bounding box changes, so let's say I have this rectangle, I have a shape class. What if my bounding box is going to be different? Or let me see here. Get the background color. They're all going to be different. Is selected, is focused. I want to see intersect point. There you go. Notice the word virtual is in there. That's a dead giveaway that I'm doing something special with this. Every single child class, not everyone, but most of them, will take intersect point and will modify it. So when I have a circle 2400, I re-implement this. I have already done this in the code that you have, re-implemented the intersect point. So because whether I'm intersecting a circle is not the same as intersecting in a rectangular box. Rectangular box is just, is the point within this space? With a circle, is it a certain distance from the center of the circle? That'll tell me how far, like I get the distance between the mouse point and where the center of the circle is. That distance, if it's greater than the radius, it's not in the circle by math, right? If it's less than the radius, it is in the circle. I can even show you that right here. Where is intersect point? Intersect point. Okay, so if it's in the rectangular bounding box, that's what that thing says, then I get the bounding box again. Okay, fine. I get the center of the bounding box where the circles, that's how I know where the circle's being drawn. It's drawn right in the center of the square. I get the distance from the point X, Y to the center of the circle. That distance right here, that's Pythagorean theorem, right? I'm just getting the distance between where my mouse is and the center of the circle. Is that distance less than the radius? If so, presto, it's done. We're in the circle. That's all. But it's different than the rectangle. So I have to make another version of that function. That's what inheritance gives me. I can make different versions of different functions. I get all the variables for free. I get all the functions for free from the parent, and then I modify the ones I need. I'm trying to minimize the amount of stuff I have to redo. I'm trying to be as lazy as humanly possible. Okay, and if it's not in the bounding box, well, I don't do anything. Just get out, done. I can get the area. What's the area of the circle? Well, it's the radius times pi, pi r squared. That's if I wanted that, right? What's the radius of a rectangle, though? It's width times the height. It's not the radius squared times pi. It's the width times the height. I need a different thing for a circle versus a rectangle. I can give back the radius, for example. I can, and here's a paint method, for example. All right. But notice I don't have that many functions in here. I only redo the functions that are different. Okay, let's see. And triangle's going to have the same kind of thing. But I would like to point out, triangle 2400 has already been refactored. So shape 2400, it was a model view controller. So I said, okay, instead of one class, I'm going to have three. Here are my three classes. Class number one, I could have called it shape model. Excuse me. I just kept the same name. You could have called it shape model and that would have been perfectly fine, right? Here's my model. It's a generic model. It keeps all my stuff, right? It is the database of my objects, right? It's keeping whether it's being dragged, it's keeping whether the mouse is on it, it's keeping the color of the background, it's keeping this, it's keeping that, it's keeping the bounding region, width and height. Okay, that is the model. Okay, the end of the model. All right, here's the view, the shape view. All it deals with is painting crap. I can set the model because it needs to know about the model. The model has all this data. I can't paint squat unless I know what the data looks like. So it needs to know about the model. And it has grand total of two functions that do any work. It has paint and it has paint outline. Paint outline is going to be the exact same thing for every single one of these shapes. So you don't need to re-implement that one. That will never change. It's just the little dashed outline that you have around outside the shape. That's it. Okay, so paint outlines, I don't need to change this at all. And then I have a controller. And I'll give you a little hint. You don't need to change a controller. You were here listening, so that's good enough for me. I'll give you answers, right? You don't need to, there's no child class of this shape controller needed. What's going to change between when you're dealing with a mouse controller and you have an intersect point in the model? What do you need to be different? Does the rectangle do anything different? No, it still deals with the mouse. Same way. Does it deal with the timer? No, it doesn't deal with the timer. How about the circle? No, it doesn't really do anything with the circle either. All this thing does is it handles mouse events. And since the mouse events are going to be handled the exact same way, irrespective of what shape you're dealing with, you don't need a child class. You do if you have an animating rectangle, because now you have that timer thing happening. But if you don't have the timer thing, like with the rectangle, like with the circle, like with the triangles, leave it alone. You only actually need to break into each of these things into two classes, technically. Okay, so the shape controller, every single thing has a shape controller. It just handles mouse events, and it knows about the model and talks to the model. You can even look at this later on. We'll look at that in a second. So here's triangle. My triangle 2400, it's going to be a model view controller approach. So here's the model, and here's the definition for all my model stuff. And here's my refactor code. Here's my triangle view. It does paint. I just moved the paint into that section. It needs to know about the model because it's going to be using the model to, let's say, here we go. Is it in focus, for example? That would be given to you. That would be given to you. That would be given, like almost everything's given to you except for like, if I need to go to the model to get data, I need to go to the model to get data. Okay, and that's it. That's the grand total of what the triangle view does. It paints. It has a constructor because it needs to know about the model. There is no controller because the controller is the same. I've been babbling on for a bit, so that was one of the other topics, was inheritance. We did information hiding. We did inheritance. What other things do we get? Polymorphism. Polymorphism meaning many forms. Polymorphism, like, let's see here, what's a good example? I had a perfectly fine polymorphism example 2 seconds ago, so let's find out. There we go. Oh, that's a destructor. Move by. Intersect point. Everywhere I have the word virtual. It's a form of polymorphism. As in, when I have a shape, I figure out which function I call at runtime. It's runtime polymorphism. That's what a virtual function is. So at the time, I have a pointer to a shape. What kind of shape? I don't know. I don't care. It's a pointer to a shape. And so I call, hey, do you intersect this point to that shape? The pointer to that shape. You don't know what kind of shape it is. It's just a pointer to a shape. That's what you want. I just want a big pile of shapes, and I just draw all of them or just handle the mouse for all of them. I don't want to know what kind of shape it is. I want the shape to know how to deal with itself. So I say, hey, shape, do you intersect this point? And that's when I need polymorphism. Because if it's just a shape, is it a circle? Is it a rectangle? Is it a triangle? Is it what? What is it? And the virtual table says, ask the shape which function to call. The function that the shape says, oh, call this function over there. And you call that function over there. So depending on what shape it is, it will call a different function. It's just a lookup table. Which function goes with paint? Which function here goes with intersect point? Oh, you're a triangle. Oh, so we're going to use this one over here. There's no way of knowing it otherwise. That's what one of the forms of polymorphism. Let's see other forms of polymorphism. Do we have another one around here? We'll have it in CPP for sure. I know this because we should have it right around, where would it be? Oh, I'm getting better. I probably am not getting better, but I'm going to pretend I'm getting better. Where is it? There's got to be one around here. I'm too lazy of a programmer not to have done this. Oh, it's got to be around here. Selected. Anyone want to hazard a guess what I'm trying to look for? Oh, there's one. All the way down here. So I'm doing pretty well for myself. Right here. Another form of polymorphism. What is that? Well, actually, more like that is a form of polymorphism. Casting. We say, hey, get this stock object. And instead of it being some stock object, we say, no, 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 no. It's not just a stock object. This is an H brush. It is casting data from one form to another. You say, no, no, no. It's not just a shape 2400. It's and you could have done this technically as one of the solutions, right? It's not just a shape 2400. It's a circle 2400. If we had some way of determining what kind of shape it is, and at runtime, we say, what kind of shape is it? Okay, cast it to this kind. It says, no, it might say that it is, some kind of random object, Windows object, but in fact, it's a special kind. It's an H brush, a handle to a brush. And so cast it from this form to this other form. It's more special. It's more specialized. It's not, instead of it being an integer, it's an unsigned integer. Oh, no, no, that's not a double, or that's not a float. That's a double. You can just say, no, no, I don't think the data is this kind. It's this other kind. We've done this. Every time we called malloc, we did that. We said, no, 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 it's not a void pointer. It's an int pointer. We do this all the time. That's another form of polymorphism. So we had runtime polymorphism. We had casting, which is another form of polymorphism. I'm just going to blank on all the various forms of polymorphism. We have static polymorphism. There's dynamic polymorphism, runtime polymorphism, compile time polymorphism, which would be, let me think of a good case of compile time polymorphism. Oh, that's actually, compile time polymorphism looks more like, where is it now? There you go, right here. Or this is one type of polymorphism as well, which we'll get to later. Templates. This is, I don't know what this thing is going to look like. I do not know what this linked list actually stores. I'm going to have some kind of class T that's going to be stored there. That's it. I don't know what kind of class this is. I don't know what it does. As long as it fits some set of requirements, I can store whatever the hell I want in there. We've used this before, by the way, if you didn't know. Every time we deal with, or maybe you haven't used it yet, but you're going to use it soon enough. Standard template library is just swimming in these things. It's literally there in the name, standard template library. So every time I store a kind of data, as long as it fits the pattern, I can store it. That's fine. And so this would be what ends up happening is when I go to compile my code, it figures out what classes are actually using this linked list and will make a new version of the linked list class for every kind of data being stored. It will on the fly generate a whole bunch of different classes, which is bonkers in my books. But at compile time, it figures out what kind of data it's storing. And then we also have operator overloading. So that is, I replace my plus operator with it being concatenation. So for strings, if I plus two strings together, I concatenate the strings together. I squish the strings together. I don't do math on it. I just squish the strings together. Okay. I've been babbling on like a drunken monkey here for a while. So please stop me before I climb up in a tree or something. Can anybody ask a question that will help? I know this was a lot to take in. Is there anything I can do to try and unpack some part of this or some concept here? What you're doing for that next assignment, every time I make an object, you would, let me see here, that's linked list. There you go. Every time you make a new object, there's this shape factory class. I will have a bunch of different types of shapes I can make. You may have to modify that. And every time I make a new shape, so I'm making a model, let's say. So here's a point, here's the endpoint, here's a bunch of flags. And it says, hey, by the way, what kind of shape are we making based on the flags? Like, is control down? Is shift down? What kind of shape are you making? And you say, oh, I'm making a circle. Okay, make a circle. The point of this is that you're trying to make the implementation, you want to minimize the number of classes that know how you implemented things to an absolute bare minimum. I have one class in all the rest of my code. I have one class other than the actual classes themselves, shape classes themselves. I have one that knows how everything else is implemented. In fact, the shape classes don't know how they're implemented. Only this one factory class, which builds these shapes, knows how things are implemented. Hopefully that makes some sense. I'm going to stop share for a second. Let's see if we can unpack some stuff, because I also want to see what the people wrote. All right, but I'm wondering if drawing the circle is something that we should fix in order for it to work, because it's not working for me even after refactoring the paint function. So it should be a matter of, we have a paint function for drawing a circle, drag that paint function down, that should be it. So you'll have a circle view. Oh, you'll need to add making a circle view from the factory class as well. But your circle view extends shape view. And when you make a circle, you'll change the factory class. So you will have to change the factory class a little bit. So let me show that again. That's a great question, by the way. Here we go. Here we go. Here is me making a view. If you say it's a triangle, I make a triangle view. If you say it's an animating rectangle, I make an animating rectangle view. If I have a circle, I'll make a circle view. You'll have to modify this function as well. So otherwise I won't make a view. I will just get the generic one, which is what you're actually seeing right now. That's a great question. That's something I want to answer on Piazza, just so other people see it too. Because if I don't have this stuff here, like this and this, here's what I get by default. And that's what the rectangle view gets, and that's what the circle view is currently getting as well. And that's why it looks like a gray box, because it's a shape view. It's just this generic shape view. And what you really want is, you want to create your circle view and pass that back out. It's a special kind of shape view. It just looks nicer, right? It draws a circle. And with your circle view, you would draw you would take the code from Paint that you had in your circle view, move it down to this new class, and hook everything up. It's going to let me see it. Okay. Okay. That part. Yeah, that's an important part that I probably should have emphasized a whole lot more. I know you had to change it in the factory class, but I don't think I emphasized it enough. Probably I didn't emphasize it enough. So hopefully try that out. It should be making a different kind of shape, and I definitely should respond on Piazza to answer your question a bit better. Can I unpack anything else for people? By the way, this model view controller thing, It hits polymorphism. It hits it hits inheritance. It hits polymorphism. It hits information hiding. It hits model view controllers. If you can play around with this, you make another shape, right? I made a whole bunch of them. I made a text field. I made a animated rectangle. I made a whole bunch of these different shapes, right? You can make whatever kind of shape you want in here. That's sort of the point, right? You can make. I made an arrow. I don't think I may have removed my arrow, but I had an arrow, so it was just it drew an arrow on the screen. Why not? You can make a technically. I tried it. It's pain. You can make a linked list shape. So every time you draw one of these rectangles, it draws a linked list. So a square with a line on it. You'll know what you're doing if you can make one of these things. It will solidify things. Make an animating rectangle. Make a rectangle that is, or make a shape that is a hexagon. Probably harder to do. You got to do a bunch of math. Um, or make, let me think of a good one. Parallelogram. No, that's harder to do. Right? You're just, I'm not asking for you to memorize or figure out how all this paint functionality works. Although you have drawing a rectangle, you have drawing a circle, you have drawing a triangle already given to you. You could just make a super shape which has all three of those shapes in there for the view. That would have been fine as well. But if you can do that, you really understand all the various parts and how they all work together. All right. Other questions? I'm going to be cooking supper soon. I'm also trying to avoid that. So ask your questions so I don't have to cook supper as quickly. Is everyone hoping for learning by osmosis? I know it's a lot to take in. Is there a previous topic that is confusing you or you want another example of? Oh, how would we be tested on MVC? Sorry, I can't reveal how you'd be tested on MVC. I thought we were saying let's try MVC. Sorry, how would you be tested on MVC? Here is some code. Where should this class be? What's wrong with this paint method? What's wrong with I could probably do the factory class, but or move this thing into this function to the appropriate place in this model view controller architecture. It is a lot to take in. My design process in MVC. You mean how I came up with? I didn't come up with MVC, by the way, so it's not really me. The how do I go about figuring things out? Pad of paper is really the honest to goodness answer. So the honest to goodness answer is you plan it out in advance, and with some experience, you won't hit a lot of the same dead ends each time. But I know I wanted a canvas rather than I wanted to get away from the natural Windows drawing as much as I possibly could because it's all this fiddly diddly stuff. I wanted it as insular as possible. By the way, if you have a Mac, you need a virtual machine in order to get this up and running. I apologize, but that's unfortunately how it is. So here is the original thing. Here's the original code that gets auto-generated if you make a brand new Windows Windows graphics application, which has a bunch of pre-made. Here's a timer event. Here's an H instance. Here's a title that's just generated. Here's another thing generated for you. We have an entire header file with a whole bunch of pre-made variables. There's a lot of cruft that goes into each one of these things every time I make a new GUI. I wanted to get away from that. So as soon as I could, I'm calling paint on the canvas. As soon as I'm done with this, I'm calling mouse events on the canvas, or I'm telling the canvas paint events, mouse events, and then both of those have a model that they can talk with, right? I have a model view controller for the canvas on purpose. Right? I'm always, every single one of my things, I have model, a view, and a controller. They communicate with each other, and I just figure out what kind of functions I need. So I'll lay out, oh, I need a paint function. Oh, I need a get intersect function. I need a this kind of function, get the background color function. I'm just trying to figure out how my shapes would end up working. I started off with drawing a shape, and I said, well, I would like to have a mouse over event and draw the background. Oh, well, I'll need a background color. Okay, then I'll need some way of getting the background color. So I'll need a getter method. maybe a setter method on my background color. And it's just going through the process of what do I need for this functionality, and how do I prevent myself from, how do I make sure I separate my concerns while I'm designing this thing. But the dragging and drawing things, that came from, originally this assignment was generate a whole like pre-canned bunch of shapes that always appear in the same place each and every time. And that wasn't remotely as fun as like, hey, use the mouse and draw this thing. And that was a lot more fun. And as soon as I did that, I went with that. But there's a couple iterations in this code base to get the code to look the way it does. So how was my design process? It's thinking about what I want ultimately to see and then building from there. So if I want to build a bunch of different shapes, well, the shapes are the objects themselves. I have something in the background that allows me to draw shapes on top of it. The canvas, that's an object itself. And then I build up from there. Like, what are the attributes I have? How does it draw things? Does it handle the mouse? Does it handle a keyboard event? If it's so, I need to add something for handling keyboard events. I just keep on adding to it. So you're not being asked to do something by MVC. I'm asking you simply, that's the reason it's only a 1 week assignment, to refactor 2 classes. Pull out the model, the view, the controller stuff, and put it into a different class. Or some of the functions, and put it into a different class. That's it. It should be, 30 lines of code changed, maybe less. But you need to know which 30 lines. You can't just randomly start hacking away hoping to get something, right? So think about what it should do and what it should do on the other end. And you can use the triangle as an example, because triangle 2400 does exactly what we're supposed to do. It's an example. It's teaching by example. I've done it for triangle. Just look at that for how you do it with a circle and how you do it for the rectangle. All right. Other stuff. I'm still checking Piazza, and we'll do another review session and a real, like, more formalized review session on Tuesday. I can go over the sample exam if you want me to. We can do other questions if you want to do that instead. And then on Thursday next week, that's when we'll do the exam. All right. All right. How many people do we have this time? Anyways, let's stop sharing. Okay. Well, there's 10 participants, 9 of you guys, but at least people will have the video as well. So please ask questions and practice a little bit. Just even if you do the lab, that's depressing, thank God. So even if you do the lab, so the lab for MVC is you making your own shape. It's probably more time than you would actually have for the lab, but probably a really good experience or a really good example for the kind of practice you need. How do objects work? How do polymorphism works? How does inheritance works? How does inheritance work? How do you do a model view controller? And if you can do that, then you're golden, right? That is the ultimate test. If you have that down, I'm not worried in the least bit for you guys in the exam. Okay? All right. I'm going to cook some supper for little boys. Those would be my children, in case you're wondering. All right. Talk to you guys later. Thank you.